Hello students, and welcome to Unit 4, Lesson 7 on absolute value equations. Our three essential questions for today are 1. What is absolute value? And this essential question should be a review for you. Second, what types of solutions can absolute value equations have? And we will learn that there are three different types of absolute value equation solutions. And third, how do I solve equations that contain absolute value expressions? And remember, to solve an equation means to figure out what value or values of the variable will make that equation true. So let's review absolute value. Absolute value is a number's distance from zero. So it is a measurement of distance. Here are some examples. The absolute value, and notice there are two straight lines, those are absolute value symbols. The absolute value of 5 is, well, how far away from 0 is 5? 5 is 5 units away from 0, so the absolute value of 5 is 5. Let's look at a second example. The absolute value of -5. In other words, how far away from 0 is -5? Well, -5 is 5 units to the left of 0, so it's equal to 5. Note that both 5 and -5 are the same distance from 0. It's just that +5 is in the positive direction and -5 is in the negative direction. So what is always true about the answer to an absolute value equation? And that is, since absolute value measures distance, absolute value is always equal to a positive number. You can think about it as driving your car. Whether you drive your car forwards or backwards, you've still traveled a distance. Each positive absolute value has two numbers that are that distance away. So if we were looking at what numbers are 5 away from 0, there will always be two of them. So if we reverse the absolute values that we just talked about, and we said what numbers are 5 away from 0, well, you would say that x could be +5, but x could also be -5, because both +5 and -5 are 5 away from 0. Here is the rule. Almost every absolute value equation has two solutions. For instance, this equation also has two solutions. How far away from 0 would q be if it equals 100? In other words, what values are 100 away from 0? Well, what's inside, which is q, could be +100, because it could go 100 to the right of 0, or what's inside could be -100, because you could go to the left 100 from 0. So q could be positive or -100. And this symbol right here is an or statement. It just means positive or negative. Now remember, we said almost every absolute value equation has two solutions. So how will you know if it has two solutions? Well, an absolute value equation has two solutions when the absolute value is equal to a positive number. And notice, this absolute value symbol is isolated. There's no constants multiplying it or being added or subtracted to it. When absolute value is equal to a positive number, there will always be two solutions. Now, there are also some special solutions. Some absolute value equations have one solution, and some absolute value equations have no solution. I'm going to show you some examples of those. Let's start here. Remember that absolute value is a distance, and distance is always positive. So can any distance ever be equal to a negative number? And the answer is no. So anytime that the absolute value symbols equal a negative number, there's no solution. There is no distance that can be equal to negative 2. In other words, you can't take out your ruler and measure negative 2 inches. Now in this example, we have that the absolute value is equal to 0. Well, how many numbers do you know that are 0 away from 0? There's only one. The only number 0 away from 0 is 0. So whenever you have your absolute value equal to 0, the amount inside has to be equal to 0. And that means that there's only one solution. So let's summarize the types of solutions there are to absolute value equations. When the absolute value symbols are isolated, meaning the only thing on that side of the equation is the absolute value symbols and what's inside, if the absolute value equals a positive number, there will be two solutions. So for example, if the absolute value of x equals 10, this would have two solutions because it's equal to a positive number. If the absolute value equals 0, there will be one solution. So for instance, if the absolute value of an amount is equal to 0, you will know that there will be one solution. And last, if the absolute value equals a negative number, there will be no solution. So if you see your absolute value symbols and what's inside, which can be more than one term, equal to a negative number like negative 2, you will know that there is no solution because distance cannot be negative. Now let's talk about the steps to solving an absolute value equation. First, you have to isolate the absolute value symbols. So for example, if we have 2 plus the absolute value of x equals 6, the absolute value symbols are not simplified. So we have to take away that constant from each side. 2 minus 2 will be 1, or 0. 0 plus absolute value of x will be the absolute value of x equals 6 minus 2, which is 4. This is an isolated absolute value symbol, whereas this was not. So our first step is to isolate that absolute value symbol. Our second step is to observe whether your equation will have 2, 1, or no solution. In other words, does it equal a positive? Does it equal 0? Or does it equal a negative number? Now, depending on what you observe in step 2 will decide which of 3 steps you will take. So if you determine that 2 solutions exist, this will be your step 3. If 2 solutions exist, understand that the value inside of the absolute value symbols could be positive or negative. Create 2 equations that can be used to find the 2 solutions. Then solve them, meaning use the order of operations. Now, if you observe and you see that there will be one solution because it equals 0, then this is step 3. If one solution exists, set the value inside the absolute value equal to 0 and solve. And last, if you observe that there is no solution, which would mean it equals a negative number, then write no solution because distance can never be negative. Alright, let's look at some 2 solution examples. We have the absolute value of x minus 3 is equal to 4. Now ask yourself, is the absolute value symbol isolated? Here's the absolute value symbol. And the answer is no because it is being subtracted 3. So if we add 3 to each side, negative 3 plus 3 would make 0, and absolute value of x plus 0 would be the absolute value of x. Make sure you don't lose your absolute value symbols in that process. 4 plus 3 makes 7. Now, Our second step, now that we've isolated the absolute value symbols, is to observe what type of solution we have. We have it equal to 7, which is equal to a positive, so we know there will be two solutions. What's inside, and this is step 3, what's inside the absolute value symbols could be positive or negative 7. So in this case, since x was the only term inside the absolute value, we have our solution. X is either positive 7 or negative 7. And you can still substitute back in to make sure you're right. Put positive 7 in there. What's the absolute value of positive 7? 7. What's 7 minus 3? 4. Alright, put negative 7 in there. What's the absolute value of negative 7? Positive 7. So it's 7 minus 3, 4. Alright, let's look at another example. Alright, first step is to make sure that your absolute value symbols are isolated. Are your absolute value symbols isolated? And the answer is yes, because there is nothing on this left side of the equation outside of the absolute value symbols. All of this is the value inside of the absolute value symbols. Do you see that? Now, what that means is we have isolated the absolute value symbol, so we can go to step 2 and decide how many solutions that we have. Well, we have that it's equal to 40, which is equal to a positive, so we know that there'll be two solutions. So we know that the value inside of our absolute value is either equal to positive 40 or negative 40. So it could be 40 away from 0 on the positive side or 40 away from 0 on the negative side. Now that x is not isolated, we're going to have to create two equations, one for positive 40 and one for negative 40. So we know that x plus 12 could be positive 40, but also that x plus 12 could be negative 40. Now, we'll subtract 12 from each side to isolate the variable. Positive 12 minus 12 makes 0, so I get x equals. Now I have positive 40 minus 12, so if I regroup that, I get 28. Now I have to solve this equation as well. Same inverse operation, subtract 12 from each side. Positive 12 minus 12 makes 0, so I get x plus 0, or just x, equals negative 40 minus 12. If I owe 40 and I owe 12, I owe even more, so I owe 52. So x is equal to 28, or x is equal to negative 52. These are the two values of the variable that will make the equation true. Notice I put or there because it has to be one or the other, not both at the same time. Let's try another example. We have 4 times the absolute value of x plus 2 equals 20. Now ask yourself, is the absolute value symbols isolated? And the answer is no, because we have multiply 4 outside of those symbols. Well, what's the opposite of multiplying 4? Dividing 4. So make sure you do it on each side. 4 divided by 4 makes 1, and 1 times anything is just itself, so we're left with the absolute value of x plus 2 equals 5. Now that we've completed step 1 and isolated the absolute value symbols, we can make a decision about what type of solution we have. So we see that it equals a positive, so we know there'll be two solutions. Now, third, we can write our two equations. What's inside, which is x plus 2, could be either positive 5 or negative 5. So we have to write an equation for each. X plus 2 equals 5, or x plus 2 equals negative 5. Use inverse operations to isolate the variable, and we get x equals 3. Do the same to the second equation, we get x equals negative 7. So for this equation, the solution is x is either 3 or x is negative 7.